Intrinsically safe, in the context of the National Electrical Code, refers to equipment or systems designed and constructed to be inherently unable to produce enough energy to ignite a flammable atmosphere. These systems are critical for safety in hazardous locations where flammable liquids, gases, or vapors are present. Their primary purpose is to prevent accidental explosions or fires by ensuring that no ignition sources are present, even in the event of equipment failure or damage. Key characteristics of intrinsically safe systems include limited energy, specific construction, enclosure design, independent circuits, and certification. Firstly, limited energy is a cornerstone of intrinsically safe design. These systems are designed to operate with very low energy levels, typically below hazardous levels that could cause an ignition. The energy is carefully controlled to prevent the generation of sparks or heat that could ignite a flammable atmosphere. Secondly, construction plays a vital role. The equipment is specifically designed to prevent the generation and accumulation of excessive heat, sparks, or electrical arcs. Materials and components are selected to minimize the risk of ignition, and the overall design focuses on preventing any potential ignition sources. Thirdly, enclosure design is crucial. The enclosure of the equipment is often sealed to prevent the ingress of flammable gases or vapors. This helps to isolate the electrical components from the surrounding atmosphere, reducing the risk of ignition. The enclosures are designed to withstand the pressures that may occur in the event of an internal explosion, preventing the propagation of the explosion to the surrounding environment. Fourthly, independent circuits are often utilized. Intrinsically safe systems are often isolated from other electrical systems to prevent any potential for energy buildup from external sources. This isolation ensures that the intrinsically safe circuit remains isolated from any potential faults or overvoltages that could occur in other parts of the electrical system. Fifthly, certification is a must-have. Intrinsically safe equipment must be approved and certified by a recognized testing laboratory to ensure compliance with specific standards and requirements. This certification process ensures that the equipment meets the necessary safety standards and is suitable for use in hazardous locations. The certification process typically involves rigorous testing and evaluation to ensure that the equipment meets the required safety standards. Intrinsically safe systems are commonly used in various industries, including chemical plants, oil and gas refineries, pharmaceutical manufacturing, mining, and marine applications. In chemical plants, intrinsically safe systems are used to control and monitor processes involving flammable chemicals. In oil and gas refineries, they are used to control and monitor equipment in areas where flammable gases and vapors are present. In pharmaceutical manufacturing, they are used in processes involving flammable solvents. In mining, they are used to control and monitor equipment in underground mines where flammable gases are present. In marine applications, they are used on ships and offshore platforms where flammable gases and vapors are present. To maintain the integrity of intrinsically safe systems, several practices should be followed. Firstly, proper installation is paramount. Intrinsically safe equipment must be installed according to the manufacturer's instructions and relevant standards. This includes ensuring that the equipment is properly grounded and that all connections are made correctly. Secondly, regular inspection and maintenance are essential. Intrinsically safe equipment should be regularly inspected and maintained to ensure that it is in good working order. This includes checking for any signs of damage or wear and tear, and replacing any faulty components. Thirdly, proper training is crucial. Personnel working with intrinsically safe systems should be properly trained in their operation and maintenance. This includes understanding the principles of intrinsic safety and the potential hazards associated with flammable atmospheres. Fourthly, adherence to standards is critical. All work on intrinsically safe systems should be carried out in accordance with relevant standards and regulations. This includes the National Electrical Code, as well as any other applicable local or national regulations. Fifthly, proper documentation is a must. All work on intrinsically safe systems should be properly documented, including any changes or repairs that are made. This documentation should be kept up to date and readily available for inspection. Understanding the different types of hazardous locations is also important. Hazardous locations are classified based on the type of flammable material present and the likelihood of its presence. The National Electrical Code defines 3 classes of hazardous locations. Class 1 locations are those where flammable gases or vapors are present. Class 2 locations are those where combustible dusts are present. Class 3 locations are those where easily ignitable fibers or flyings are present. Within each class, there are also divisions and zones that further define the degree of hazard. Division 1 locations are those where the hazardous material is present continuously, intermittently, or periodically under normal operating conditions. Division 2 locations are those where the hazardous material is present only under abnormal conditions such as equipment failure or accidental release. Zones are used in the European system for classifying hazardous locations and are similar to divisions. Zone 0 locations are those where the hazardous material is present continuously or for long periods. Zone 1 locations are those where the hazardous material is likely to be present under normal operating conditions. Zone 2 locations are those where the hazardous material is not likely to be present under normal operating conditions but may be present for a short period. Intrinsically safe systems are designed to be used in specific hazardous locations depending on their certification. It is important to ensure that the equipment is certified for the appropriate hazardous location before it is installed. The certification label on the equipment will indicate the hazardous locations for which it is approved. In addition to the National Electrical Code, there are other standards and regulations that govern the use of intrinsically safe systems. These include the International Electrotechnical Commission (IEC) standards, which are widely used internationally. The IEC standards provide detailed requirements for the design, testing, and certification of intrinsically safe equipment. There are also various national standards, such as the European ATEX directives, which specify the requirements for equipment used in potentially explosive atmospheres in Europe. It is important to be familiar with all applicable standards and regulations before working with intrinsically safe systems. Understanding the principles of intrinsic safety is essential for anyone working in hazardous locations. By following the proper procedures and using certified equipment, it is possible to minimize the risk of explosions and fires and ensure the safety of personnel and equipment. Remember to always consult the National Electrical Code and other applicable standards and regulations for specific requirements and guidance.